You're recording. Okay, now it's recording. Okay, now I'll try. The screen is still being shared, right? Yes. By the way, can everyone hear me okay? Is the sound okay? So someone has to unmute and say something. Guys, can you hear me?
Yes, you can.
Okay. Can you see the slides? So lecture 1, introduction to optimization. Can everyone see the slides?
Yes.
Yes. Okay. Okay. Great. All right. So the first lecture, and we'll go until I'll talk until 3, and then we'll take a short break for 15 minutes, and then continue. Just to let you know. Okay. So our goal with this first lecture is to start by giving a short introduction to optimization and heuristics. We'll look at some general steps in solving optimization problems. So going from actually formulating a problem to modeling the problem to optimizing for the problem, but we'll talk about these steps at a high level for now. We'll look at some different types of optimization models, from mathematical modeling to constraint programming and so on. And we'll see then if we have time today to get to giving an introduction to combinatorial optimization and some typical problems that we will also look at over the course of this semester. Whoops. Sorry. Okay, so why optimization? Well, first of all, I'm sure that many of you have, over the course of your studies, come across some cases where you've needed to optimize for something. Obviously, there are countless applications in pretty much all domains. So some kind of optimization used just in pretty much every type of industry, whether it's trying to maximize some kind of a profit, minimize some kind of costs, maximize quality, and so on. So pretty much every process can potentially be optimized. A lot of the newer, so let's say going back to some kind of linear programming, stuff like this was actually first introduced during World War II. Let's say these heuristics that we use nowadays, there was a big boom, let's say 40 years ago, 30 years ago, and so on, when really a lot of these heuristics were being developed and started to be put to use. So pretty much, like I said, any process can potentially be optimized. Personally, my, let's say, area of research is related to quality of service, quality of experience for various types of multimedia services and networks. So like I said, I work at the Department of Telecommunications. Some problems that we tackle, for example, is how to optimize either this quality of service or what we refer to as quality of the user experience given certain constraints. So for example, how to configure, let's say, a video stream, how to configure video parameters given limited resource allocation in the network, given limited bandwidth, processing capabilities, and so on. So these are some examples. Of course, many problems that we come across are actually too complex in terms of the search space or the amount of potential solutions, and they become intractable to solve exactly in a reasonable amount of time. So finding an optimal solution is not feasible, not possible in any reasonable amount of time. And actually, in practice, we are in many cases satisfied with finding a good enough solution, which is not necessarily optimal, but that can be found quickly. So in this case, we are interested in finding a solution quickly, which is, like we said, good enough. The notion of heuristics, it comes from the old Greek word heuriskin, so the art of discovering new strategies. Like I said, heuristics are algorithms which do not guarantee optimality, but usually find good enough solutions in a reasonable amount of time. I already mentioned the term meta-heuristic. This term was introduced by Fred Glover in 1986. And like I said, this refers to some kind of, let's say, general methodology or a template that can be used as a guiding strategy in designing various heuristics to solve optimization problems. So you have some kind of a template for, let's say, a pseudocode for an algorithm, and of course, then you adapt it to a given problem. So meta-heuristics are generally applied to types of problems when I know it when I see it kind of problem. So you don't know the optimal solution. You don't really know how far away from the optimal solution you are. Brute force is out of the question. But if you find a solution, you can, let's say, somehow assess, of course, you can assess how good it is and decide whether it's a good enough solution or not. Okay, so when we look at the basic steps in solving optimization problems, this general high-level decision-making process always consists, let's say, of these three steps. So first of all, the key thing is to identify and formulate the problem. So we have to, this step, the initial step, basically consists in defining what is the objective, what is it that we're trying to do. Are we trying to maximize something, minimize something? What are the decision variables? What are the constraints, and so on? After that, we have to come up with some kind of a model of the problem, and in many cases, this is some kind of a simplification of reality. So the actual model is some kind of an approximation of, let's say, a real-world case that we apply in order to be able to efficiently solve the problem. And we'll get to an example in a moment. But so following, after we have modeled the problem, then we optimize. So we decide on what kind of algorithm and how we're going to try to find a solution to the problem, whether we can find an exact solution or we can apply some kind of a heuristic. And once we find a solution to the problem, then that actual solution can be, let's say, implemented practically. If the solution is unacceptable, then maybe we can change the model or the optimization algorithm, or something has to be improved. Okay. So, like I said, we start with identifying the problem. Here, the main thing is to identify what is the objective, what are the input parameters, what are the constraints. It may be imprecise depending on how much information we know, whether there are some stochastic components or some uncertainty in the input parameters, or whether everything is, let's say, static. Then we need to model the problem. Like I said, this is some kind of usually a simplification of reality, some kind of an abstract model. And finally, we try to find either an optimal or a suboptimal solution using a given heuristic or an algorithm or exact algorithm that can find an optimal solution. When we talk about identifying the problem, like I said, I'll skip over these slides because we already mentioned this. We, like I said, have to identify the objectives and the constraints. When we model the problem, like what we need to keep in mind is that if we find an optimal solution to the model, that this is usually a solution for the abstract model and not for the original. So depending on how good our model is, that's how we're finding actually a solution to the model itself. There are basically two common approaches. So if we have a certain problem, we can specify a simplified model. And maybe because we have now simplified the model, let's say defined a linear objective function or so on, makes it possible to find an exact solution. But in that case, our exact solution is for a simplified model. However, if we want to keep a precise model, then we may need to, given the complexity of the situation, find an approximate, or use some kind of heuristics, or find an approximate solution because the model itself is too complex for us to be able to find an optimal solution. And in many cases, such an approach is actually where we would use some kind of heuristics and so on. Okay, what I want to do now is I want to just give you an example of a problem formulation, just to illustrate a bit this concept of simplifying a model and versus finding a precise model. Let me just switch to this whiteboard. So can everyone see this whiteboard?
Yes.
Yes. Okay. Okay. So throughout the course, actually, I'll give you guys some examples just to illustrate also how you might formulate certain problems. In case I don't know how many of you have some already experience in formulating certain problems or not. But okay, let's go through an example. So let's say that we have a company that has n warehouses. So let me start by. Oops. Sorry. Hold on. Okay, so we have, let's say, hold on just 1 second. Why is this not working? Okay, it should be okay. Sorry, my pen is not working. Just 1 second.